Okay, can you see my screen? Okay, so let us start. Now today we are starting with the one of those four important modules that we have in any OS kernel. Those four, okay, can anyone tell me what are those four important modules or functions that any OS kernel provides? Can anyone list me for that? List that for me. Okay, file management, then process management, okay, IO management, correct. Still one more, yes, memory management, correct. So these are the four big and most important modules that any OS kernel does have. So one of them is process management. And to understand how OS performs process management, first we need to understand process itself. So we are starting with this process description and control. So this is what we are going to discuss throughout this chapter, how processes are represented and controlled by the operating system. Okay, so what is the manifestation of process, that we will understand, and how OS controls them. Then we will discuss the process states which characterize the behavior of the process. Okay, let's say whether process is running or it is waiting for IO or it is suspended, what is the state of the process, right? So that is what will be looking at. Then data structures which are used to manage these processes, because ultimately process is some entity which is there in the system. So definitely there are some data structure required to manage these processes. And then ways in which the OS uses this data structure to control process execution, right? So we'll see how this process execution is controlled by the OS through those data structures. And finally, we'll discuss process management in Unix System 5 Revision 4 in a very brief way, right? We'll not be going into detail, but we'll be discussing in a brief. So this is the roadmap for this chapter. And we'll start with the process representation. Before that, what is the requirements of an OS? So one of the biggest module or one of the biggest service that OS provides is process management. So OS does process management. That is the fundamental task. So the operating system must, to perform this process management, what operating system needs to do? So it must interleave the execution of multiple processes. Now, here, our most of the discussion that we are having on processes will consider that system is a single processor system. So our discussion is based on that assumption that there is only one processor. Okay, nowadays we have multi-processor systems, but to understand the fundamentals of this process management, we have assumed here that there is a single processor. And when we have a single processor and still there are multiple processes which are running, okay, how it happens? That happens because of interleave of the execution of multiple processes, and OS needs to provide that service. It has to support that. So first, OS must interleave the execution of multiple processes. How that happens? How multiple processes can run on a single processor at the same time, right? That is the biggest question. So we'll see that. Then second thing that OS needs to do is allocate resources to processes and protect the resources of each process from other processes. And here resources can be memory or IO, right? When one process is working on one file, other process also wants to work on the same file. It has to be protected so that there is no clash between those two processes to use a single resource. So that is one thing. So protecting resources. Then enable processes to share and exchange information. That is IPC, inter-process communication. If there are multiple processes and they need to talk to each other, they need to share some data, they need to say, send message, get response. If that all thing is required, OS has to support that. And then finally enable synchronization among processes. So synchronization means when one process is running and waiting for other process to produce some result, okay, that other process will wait, and when one process completes its job, the second process will consume that result produced by the first process, and they have some synchronization between them. They are working in a sync. So these are the four important things that operating system has to do to perform or to manage processes. Does this make sense to everyone? Are you getting what OS needs to do for process management? Okay. So now let's start. What is a process? Again, there are a number of definitions given, and we are going to list 4 of them which are given in the book. A process is nothing but a program in execution. So when you run any program and when it is getting executed, it is called process. Similar to that, an instance of a program running on a computer, very similar to the first definition. The third definition, it is the entity that can be assigned to and executed on a processor. So it is the entity that you assign to a processor and can be executed on that processor. So that is again a process. The fourth definition, a unit of activity characterized by the execution of a sequence of instructions. So now here you see unit of activity characterized by the execution of a sequence of instruction. And what is sequence of instructions ultimately? If I want to put it in a short, what is the sequence of instructions? Program, right? So basically it is program. So execution of a program, a current state, what is the state of that process, and an associated set of system resources. What resources are associated with that process, that entity which is being executed? Like what memory is there, what IO is there, what resources are associated. So combinedly, this is going to characterize a process. Does this make sense? The last definition, right? So what are the elements of the process? What are the elements of any process? So a process is basically comprised of, first thing is program code, right? It is a program code and possibly shared. We'll discuss why it is shared. I'll give you an example, possibly a shared program code. Now, can you tell me what can be there apart from program code, which is a part of the process, or which is one element of the process? Can you think about this? What else can be there? One is program code, because a program which is running, it is called process. Resources, fine. See, resources, they are assigned to process, but resource itself is not part of process, right? Resource itself is not part of process. They are used by the process, like IO resources and processor itself, memory, that is also resource. What is the element of process? One is program code, another a set of data on which this code works. A set of data on which this code works, that is also part of process. Do you agree with that? Then third thing, now program is there, data is there, but to manage all this, a number of attributes describing the state of the process is required. Okay, program is one thing, data is another thing, but only that those two things cannot create a process. because to manage all this, number of other things are required, number of attributes are required. So number of these attributes describing the state of process, that is also part of process element. That is also part of process element. So these are the three main elements. Now we are going to dig out further, rather we are going to dig in further in the last part, because first two are simple to understand, program code and set of data. That is simple to understand. Now we'll be discussing more on the last part. What kind of attributes, what do you think, what kind of attributes are required to describe a state of the process? So while the process is running, it has a number of elements, including this kind of attributes. Identifier. Yeah. Yes, I told you that I will discuss that. Program code, shared program code. That's simple. I am giving you a simple example. Let us say you have opened MS Word file. Is it possible that I can open another MS Word file? It means, can I have more than one MS Word file open at the same time in my system? Is it possible? So they are different instances of MS Word program. So now these two processes, these two MS Word files that you have open, they are two processes and they are sharing the same code, that is MS Word code. Simple. Okay. So what are the attributes that we can have within a process or for a process? One is identifier. The very first thing is every process must have some ID, right? A unique identifier associated with the process. Then state of that process. We are going to discuss what are the possible states of any process. If the process is currently executing, it is in the running state. Simple. Because at its, you can say at the very simplest, in the very simplest form, we can say that either process is running or it is not running. Do you agree with that? So when process is there, either it is running or it is not running. So these are the two very basic states of any process. And we will start discussion of this process states just after this process elements with those two states only. Then there is a priority of the process. Sometimes processes are having different priorities. So it is there. Program counter, definitely the address of the next instruction in the program to be executed. That is required. Memory pointers includes pointers to the program code and data associated with this process, plus any memory block shared with other processes. So pointers to all these different memories, they are required. Context data. These are the data that are present in registers in the processor while the process is executing, which creates a context of that process. Okay, so this is another element. IO status information. It includes outstanding IO requests, IO devices assigned to this process, a list of files in use by this process, and so on. So you require information, status information on all these resources which are assigned to a process. You need to maintain that. Then you may need to maintain accounting information, which may include the amount of processor time and clock time used, time limits, accounts numbers, and so on. So these are the different attributes which need to be managed by OS, and that is part of process itself. So these are kind of metadata. Can we say that it is kind of metadata? Because main data of any process, it is program and the data on which that program works. But to manage all this program and the data in the process, you require some extra information. You require some extra status that you need to maintain. And these are some of those status. And again, these are very general information that I'm giving you. Depending on the operating system, there can be variations. Depending on the operating systems, there can be some variations. But this is in general, this kind of information need to be managed to manage a process. So does this make any sense to you? Yes, guys. Okay. Now, there is a concept called process control block. Okay. And you can see the attributes or the information that we just discussed. They are all part of this block called process control block. It is one data structure. Basically, it is nothing but a data structure which contains all this process related information. Okay. So it contains the process elements created and managed by the operating system. Definitely this process control block, it is created and managed by OS. It allows support for multiple processes. How? We will see. Thus, we can say that a program, a process consists of program code, associated data, and all those attributes which are maintained within this data structure called PCB. That is process control block. So now those information are part of this data structure called process control block. So do you agree with this last statement, or do you understand this last statement? So process consists of program code, associated data, and PCB. Now, before we start understanding process states, let's understand how these processes are running on a single processor, right? When we have multiple processes to run, how they are running on a single processor. Okay. Can you just guess something? I mean, how it is possible that if you have a single resource and you need to share that single resource between multiple entities who want that resource, what do you do? What is the simple way to do that? Just think about it. When you have a single resource and there are multiple entities who want that resource, how you manage it? Right, one kind of scheduling is required, correct? Okay. So sometimes priority based, right? Sometimes it is priority based, sometimes it is fair scheduling, sometimes it is fair scheduling. Okay, but if you want to give them satisfaction that all of them are using the same resource at the same time, and if you want to give that kind of satisfaction to all those entities, what is the best way? Have you observed a group of kids playing with the same toy? Have you ever observed a group of kids playing with the same toy? How they manage it? How parent manage that situation? Because if everyone wants the same toy, how parent can manage that? It's very simple. Allow one first kid to play with that toy for some time, then it will be passed on to second kid. He will play for some time, then it will be passed on to third kid, and he will play with that for some time. So basically you are slicing, you create a time slot for each kid to play with that toy. Priority based allotment of toy actually doesn't work with kids. Okay, you need to take my words because I am a parent. So priority based allotment is not possible with toy, but it is like, you know, we try to manage that with the idea that, okay, you play for a few minutes, then it will be given to other kid. You play for a few minutes, then it will be given. So this is the same idea where, I mean, which is used here. When you have multiple processes and a single processor, so not every process is running at the same time, but at a time only one process is running. Immediately then after some time that processor is executing another process. Then after some time some other process. But collectively the result that you get, you feel that all processes are running at the same time. Why? Because the time slot or the time slice which is allocated for every process to run, it is so small for us, for a human user to recognize that, to identify that it is block and other processes running. We cannot recognize because it is very small amount, maybe in milliseconds, and we cannot see that. And that's why we get the feel that every process is running at the same time, though we have a single processor. Does this make sense to you? Okay, so that is what we are going to see now, how it happens. So the behavior of an individual process is shown by listing the sequence of instructions that are executed, and the list is called a trace. Now there is a small program called dispatcher. Dispatcher is a small program which switches the processor from one process to another. It is like a parent who is getting toy from one kid and giving it to the other kid. So that parent is a dispatcher. In some cases, we also call it scheduler. So either it is called dispatcher or scheduler. But scheduler term, it's a general term. There are two different types of scheduler, long term, in fact, three types of scheduler, long term, mid term, and short term schedulers, which we will discuss later on. Okay, so this dispatcher is basically short term scheduler. So dispatcher is a small program which switches the processor from one process to another. So let us understand this. So this is our main memory. You can see the diagram on the right side. This is a main memory which contains three processes: process A, B, and C. Process A starts at address 5000, process B starts at address 8000, and process C, it starts at address 12000. And there is a small program called dispatcher, which is part of the OS. This program, it is a part of OS, and it starts with address 100. Okay, so consider these three processes being executed. All are in memory plus the dispatcher. Let's ignore virtual memory for this. So right now we are ignoring the idea of virtual memory, which we will discuss later on. Now this is the trace of each process. Now trace is nothing but the listing out the instruction, okay, which are going to be executed for that process. So as I told you, process A starts with address 5000. So when I say process A starts, means that instruction of that program, it starts with 5000 and it ends on 5011. So these are the total 12 instructions which are there in program A. In program B, there are 4 instructions. In program C, again, there are 12 instructions. Okay, and these are the addresses where instructions are stored. So we are just trying to simplify this idea. Now, these are the trace of the processes. But do you think that it is going to be executed sequentially? That, okay, first all these 12 instructions, and then process B, 4 instructions, and then process C, all this? No, that is not going to happen. How it will be happening? This is some idea. For first 6 instructions of process A, they will be executed for some time, and there will be timeout. Now, scheduler or dispatcher, that will run for some amount of time, basically 6 time slots, you can say, or 6 units of the time. This unit can be anything, millisecond or anything like that. Now, this blue, the things in the blue, that is the dispatcher code which is running. You can see it is starting with instruction 100 and up to 105. So this dispatcher will run and it will decide that which process will run next. So it has decided that, okay, process B will run next for some time. And as process B does not have much instructions, it is completed within 4 time units. So again, there is IO request. In fact, in process B, there is in between, there is IO request. It is not completed. Process B, it is not completed. There is some IO request which has come, and IO request is like you want to access some disk or some other IO devices, which is a very slow operation. So when there is IO request, process is going to sleep for that amount of time, for some amount of time. Okay. So as process B is now going to sleep, it cannot execute further any instruction for a while. Dispatcher comes again. Okay. And now what it will do, it will kick out this process from the processor and allows another process to run for some time. Then timeout occur. Then again dispatcher comes, allows some time to other process. Again timeout, again dispatcher, again another process. So this is how it is going to happen. This is how it is going to happen. So this is the processor point of view. Okay, this is the processor point of view. This is process point of view, because for a process, it thinks that I am executing my all instructions in a same sequence that I need to do. So this is process point of view, but from processor point of view, it is interleaving. This is called interleaving of processes, and OS handles that through this dispatcher. Are you getting? Okay. Okay, there is a question. The number of instructions run by dispatcher. The process must also run the same number of instructions, 6 in this. Not always required. Normally what happens, dispatcher, it is a very small program and it runs for very small time. Sometimes the time slot which is assigned to process, it is bigger than dispatcher. Okay, and it has to be bigger than dispatcher, otherwise dispatcher cannot finish, right? Does this make sense, Dave? Okay. So that is our first part, the process representation, and okay, we'll see the control, how it is controlled, but PCB is the main entity through which you can control the process. Now we are going to discuss about process states, okay, which characterize the behavior of process. So now we are going to discuss more on process states. I hope up to this point it is clear. This is interleaving of processes. Now, as I just told you that any process, at least it can be in any of these two states. Either process is running, it means a processor is executing it like this. Okay, here the process A is running. Okay, at this moment, for this 6 time units, process A is running. So it is in running mode. But other than this, for this time slot, for this time period, for this time period, for this, until unless it comes to this point, for all this time period, process is not running. Okay, so these are the two very basic states of any process. It is called two-state process model, and it can be either in running mode or it can be in not running mode. So you can see that dispatch is the state transition when process is not running and dispatcher decides to make it run. This transition is called dispatch. It will dispatch from not running to running mode. And when time slot is over or some IO request happens in between, that running process will switch back to not running state. And that is called pause, because it is possible that process is yet not completed. Either time slot is over or there is some IO request, because of which this process needs to be stopped for a while. And that's why it moves from running state to not running state. And that is called pause. So dispatch from here to here, and from running to not running, it is pause. If process completed, while it is running, it is completed, it's over. So in that case, it will exit from the system. And whenever new process comes, it will enter into this state. So this is a very basic two-state process model. Does this make sense? Yes, guys. I hope you all are awakened, right? Now, okay, can anyone tell me how many processes can be there in running state at any instance of time? Only one, definitely, because we have assumed that we are talking about single processor system. That is our assumption, right? So all our discussion is based on that assumption that we have a single processor. And as we have single processor, at a time only one process can run. How many processes can be there in this state at any given time? So when we don't know a fixed value, we denote it with n. So there can be n number of processes. We can say that there can be n number of processes, right? So now, if there are n number of processes in not running state, what data structure is suitable to maintain this not running processes? If I want to maintain multiple processes in this state, which data structure is suitable? If you have gone through data structure subject, you should be able to answer this question. Exactly, queue is the best data structure because queue is like first in first out, and if there is no priority, it should be first in first out. So this is queuing diagram. This is the queuing diagram for two-state model. So here on a processor at a time there is one process. These are the not running processes which are maintained in a queue. It will be dispatched one by one, and when this process is paused, it will join this queue from the rear end, and dispatch will happen at the front end. And then if process ends, it exits, new process enters at the rear end. So does this make sense? Okay, so this is how actually it happens. In real OS, they use queue data structure to manage all these processes. Okay, now tell me, before we go further and we look at the other diagrams, let us understand a little bit about this process birth and death. Okay, let us understand about this process birth and death. What are the possible reasons for creation of any process and termination of any process? So these are some examples. These are some possible reasons. For an example, in batch system, I hope you remember batch system. Do you remember batch system? We discussed in second lecture. Okay, so in batch system, what happens? You submit a job, and then after that job, that program, when it will start, it will become a process. So because you inserted a new batch job, it will create a process in the system. So that is one possible reason. Another is interactive logging on time sharing system, where a single CPU is being shared by multiple users through different terminals. And if user logs in, nowadays you can think about servers. When you logs in, a new process will be created on server for you because you are trying to access it, right? So that is another reason. Interactive login is the another reason for new process to be created. Third possible reason is created by OS to provide a service. Let's say you say that I want to print something. So you say print command, and there will be a process which will be created which will take care of your printing job. So OS is creating new job for you. I mean, OS is creating new process for your job to be done. And another possible reason is spawned by existing process. Let's say you have started something. There is some process which is going on, and it needs to perform something in parallel, maybe. So it may create another process. And a very good example of request handling at server side, client request handling at server side. There is one server process for every client which comes with the request. For every request, it will create a new process, and that new process will be handling each client. So one process will be handling one client. So existing process can create new process. So these are possible reasons for process creation. These are the possible reasons for process creation. What are the possible reasons for termination? Some of the possible reasons, right? Let's say process completed, your program completed. Let's say you have written some C program and it is completed. So definitely process will be over. It will be terminated. So that is normal completion. Sometimes memory is unavailable. Your process is running, but suddenly there is a problem of memory, and because of that, process gets aborted. That may happen, and that was the one of the major reasons in earlier days when there was a shortage of memory. Okay, so memory, if memory is not enough, memory is there, because of that sometimes OS needs to abort some of the processes, so that can be another reason for the termination. Sometimes protection error, let's say some you might have observed uh, sometimes your C program that you have written, because of pointers that you are using and you are not using that pointer properly, it is possible that it is trying to access some address in the memory which is not allowed to be accessed, which is part of the kernel. And if your program is trying to do so, OS may terminate your process. That is protection error. You are trying to access resources which are not allowed for you. So that kind of error may terminate that process. Or operator or OS intervention, right? Because of some reason, OS decides to terminate your process. So there can be, again, these are very few reasons that I have listed here for process termination. There can be more reasons for process termination. Different types of errors can be there. OS has some reason to terminate the process because of memory shortage or whatever the reason is, right? So these are some reasons why process gets terminated, and these are the reasons for process creation. I don't see any other reason for process creation or any other cause which creates a process, but these are the mainly four causes or four reasons which create a process. So does this make sense? Yes, guys. So this is the same thing. The OS builds a data structure to manage the process. We have seen that. Traditionally, the OS created all processes. Traditionally, when you start your system, when you boot your system, OS start creating some of the processes. But it can be useful to let a running process create another. As I just discussed, that if there is a server process which is running, for every new client request, it will create another process to handle that request. That is the simplest example of that. So when process creates another process, which is called process spawning, when existing process creates another process, which is called process spawning, the process which is creating new process, it is called parent process. Okay. Whenever process creates new process, that process which creates the process, it is called parent process, and the newly created process is called child process. So there is always such relation between these two processes. Creator is parent, and the process which is created, it is called child process. And termination, there must be some way that a process can indicate completion. So this indication may be a halt instruction generating an interrupt alert to the OS. In batch system, when job is completed, it may generate some instruction, halt instruction, and alert the system that, okay, I am done. Okay. Sometimes user action, like when you log off on the time sharing system, or you simply close your application. Let's say you are working with MS-DOS, or sorry, you are working with MS Word, and you close that. So if there is no other MS Word program open, if there is no other MS Word file open, it will terminate that program. It will remove that program and process will be terminated. Sometimes you are working with some application and some fault occurs, and you might have observed that suddenly that application gets shut down. Have you observed that? Because of some error, your application gets shut down. Yes, have you observed this thing? So that is another way. Okay. And sometimes parent process terminating the child process. Okay, as we will progress further, you will understand what are the cases when parent process terminates the child process. Okay, but this is the little idea on process creation and process termination. I hope you are getting this idea. Now let us come back to this queuing diagram, or this two-state process model, whatever you call it. Now just tell me one thing. When the process which is running right now, what are the possible reasons that it will go in this pause mode and it will join this queue? What are the possible reasons? One is IO request. Yes. You can unmute and you can answer, no problem. If you want, you can unmute and you can answer. So what are the possible reasons that process which is running will enter back in this not running state? At least two reasons you know. You know at least two reasons, which we just discussed. So one reason is because the time slot which is allotted to that process, it is over. So now it has to go back to this queue and wait again, okay, for its next turn. That is one reason. Another reason is,
Sir, another reason is if the process is paused or it is terminated.
see, if it is terminated, it will never come back here. It will
Yes, sir.
directly go outside the
So
system.
if it is paused,
So pause means what? Another reason is it has made some IO request. It is waiting for some resource. Maybe it is waiting for printer. Maybe it is waiting for some file to open. That is IO request. And IO request is going to take time. So while it is taking that time, that process cannot proceed further. It cannot run further. And that's why it will be paused and go back to this queue. So there are at least two types of process in this queue. Those processes which are ready to run, but because they have completed their previous time slot and they are waiting for the next time slot, they are waiting here. And another is which did not complete its time slot, but because they made some IO request and they were forced to wait, they joined this queue. So there are two different types of processes in this queue. Those processes which are ready to run and those processes which are waiting for some IO event. Does this make sense? Yes. So now, if that is the case, now let's say dispatcher needs to find out the next process which can run next. Okay. So what kind of process dispatcher should select? Normally by default, what happens if it is a first in first out, it is simply get this first process from this front end and dispatch it. But if now there are two types of processes at least, those processes which are ready to run and can go on processor and start running, and those processes which are still waiting for some event. So tell me, dispatcher, what dispatcher need to do here? What it needs to do? Yes, it needs to identify that which processes are ready to run, and one of those first process. So it is possible that let's say first all these processes are waiting process and this red process is now ready to run, suppose. So it needs to scan this queue and needs to find out first process which is ready to run, and then it will dispatch it from middle of the queue, from the middle of the queue. So this is going to take time, as well as this is little complex system, not complex exactly, but this is time wasting system, right? So what do you think, how we can solve this problem? How this problem can be solved? Sorting, okay, but in that case, every time you need to perform sorting when some new process joins this queue, whether it's a new process or paused process, right? So can there be any other solution, better solution to this? So we need not to sort. Status is already maintained, otherwise dispatcher would never know that. Status is always maintained. Priority queue, again, if you use priority queue, what is the thing? Whenever process enters in this queue, you need to check its status and accordingly you need to sort this queue, isn't it? Exactly. Maintaining multiple queue, that is one possible solution. See, priority queue can be a solution. I'm not telling that it is not a solution, but better way is maintaining multiple queue, as there are two different types of processes in this queue, at least two different types of processes in this queue, ready to run and waiting processes. So rather than putting them all them in the same queue, we will put them in two different queues. And that is the next model, 5-state process model. Now there are 5 states. Instead of 2, there are 5 states. So not running state, now it is divided in 3 different states: new state, ready state, and block state, block or waiting state. Exit was always there, but it was not a state, but now it is a state and running is there. So when running process time slot is over, that means timeout occurs, it will join ready queue, and dispatcher will select process always from ready queue, because that are the processes which are ready to run. Those are the processes which are ready to run. But if any running process makes some IO request and it has to wait, it won't join ready state, rather it will join block state. And whenever that event for which it was waiting, if that event occurs, then it will join this ready state back. Then it will join back this ready state. So now it will become ready to run, and whenever turns come, dispatcher will dispatch it. So ready is one queue now, block is another queue. But apart from these 3, now we have 2 more states, new and exit. So what are these 2 states? So the running state, the process that is currently being executed, that is a running state. Ready state, a process that is prepared to execute when given the opportunity. We know this ready state. Block or waiting state, we have discussed. It's a process that cannot execute until some event occurs, such as the completion of an IO operation. So that is block or waiting state. Now what is new state? A process that has just been created but has not yet been admitted to the pool of executable processes by the OS. So you can see here in this 5-state model, okay, when process is created, the process is created, but it is not admitted in ready state. So it cannot execute. Okay. Typically, a new process has not yet been loaded into main memory, although its process control block has been created. Now this last line, you need to understand this last line. When a process is in a new state, it means it is not loaded. Its program and data is not loaded in main memory. Then what does it mean that process is created but not loaded? Process is created means that PCB, if you remember PCB, process control block, that is created and it is always in main memory. That PCB is always in main memory. Okay. So that PCB is created, but the corresponding program and the data, they are yet not loaded in the main memory. That is the new state. Are you getting this? Yes. Any question on this? And finally, there is similar to new state, there is exit state. A process that has been released from the pool of executable processes by the OS. So now this process cannot execute anymore. It is exited. But still, okay, but still the data structure, that PCB is still there, or some part of that process data is still there in the memory because of some audit reason or some performance measurement reason. Okay, so that is exit state. A process that has been released from the pool of executable processes by the OS, either because it halted or because it aborted for some reason. Those processes are called in exit state, where they cannot run anymore, but still some of the part of that process, most of the time PCB, it is still there in the memory, but otherwise program is offloaded, data is offloaded, everything is offloaded except some few information regarding that process is still there for some auditing reason. Maybe some other process wants to measure how many resources it has used, how much processor time it has used, something like that, some accounting reason. Does this make sense? 5-state process model. So we are now, we are trying to improve the design. First, we started with the 2-state model, then we improved with the 5-state process model. So we are just evolving the design is evolving from 2-state to 5-state, and further we will see. So what are the possible state transitions? Now, if you see here, these are the state transitions, right? From one state to other state, that is called state transition. When particular state transition happens. Okay. So new to ready. When new process enters into the ready state. So OS is ready to handle another process. If OS has now enough memory and it is capable to execute new process, it will allow that new process to enter into the ready state. Then there is a transition from ready to running. Okay, ready to running. Basically, when a new process needs to be scheduled on processor, dispatcher will select one of the processes from ready state and it will move it from ready to running state. So select another process to run. Dispatcher selects another process to run. Running to exit. Simple. If process terminates because it is over, it will go from running to exit state. Running to ready. Timeout. When timeout occurs, running process will enter back into the ready state. Running to block. If there is some IO event or some waiting event occurs, running process will enter into the block state. Block to ready. The event a process is waiting for has occurred, then that block state process will enter into the ready state. Ready to exit. Again, this is not shown here actually. You can't see any transition from ready to exit, but that is also possible. Okay. Can you guess a reason for this ready to exit? Is there any possibility that any ready process enters directly into exit state? It means it is terminated. Normal termination is when process completes. Even error, when error occurs, when process is running and some error occurs, then it will be terminated by the OS. But what can be the possible reason that ready process directly enters into the exit state? Can you guess any such reason? Anyone? Sometimes the ready process is a child process of, and there is some parent process of that. And if parent process exits, and parent process, if it exits, sometimes all children will be terminated. So that is one of the reasons. Let's say parent process has completed or it has some error and it is going to exit. So all children processes will be terminated. That is possible in some design, not in all designs, but in some design that is possible. So ready to exit process terminated by OS or parent. Sometimes more memory is required, okay, for some more priority processes. So lower priority processes may be, even if they are lying in the ready state, OS may decide to remove that process. So there are some possible reasons, and these are the design, possible design. Not in all OS that happens, and we are discussing general design. Okay, you need to understand one thing. What we are discussing is a general design. Different OS may have variations in this design, but this is one potential reason why any process can move from ready to exit or block to exit. There is also another reason. OS may remove block process directly because it requires some more memory. That is one possible reason. So does this make sense? Okay, at times we manually click end process through task manager. So what kind of state? Yeah, that is the same thing. Let's say your process is not running. Either it is, normally when we do this, for an example, you have opened your, hang cases, exactly. So if that process is hanged because it has moved into some waiting state, block state, you click on that and you are telling the OS, actually, you are telling the OS that remove this process. You think that you are removing, but you are actually telling the OS to remove that. So OS has its own reason to do that. OS has its own reason to do that. One of the reasons is user asked to do that. But normally you are working with your MS Office, your MS Word, you have saved your program and now you want to close that. So when you close it, it was actually in running state because you were working in that. Right? But again, this is very, difficult to tell how it is working, right? Because behind the scene, there are a lot of things happening. But normally when it is on the screen, you think that it is working. Does this make sense? Guys? Yes, are you with me? Are you getting all this stuff? Do you require few seconds to to rest your mind, to rest your brain? I can give you few seconds. See, I can go on for 2 hours, 3 hours. That's not a problem. But I want you to take some rest for a few seconds and then we can resume. Okay. So I hope you are getting the whole idea that we are discussing. Are you getting the bird eye view here? Are you able to summarize all these things that we have discussed today? I'm just, going through this slide. Yes, a good question. When a process creates another process, which state does that occur in? So it all depends on the OS implementation again. But if we talk about this general design, mainly it is a new state. It is in the new state. In hang case, is it in running or ready state? Do you think that it is in any of these two states? If something is hanged, it means it is a block process. It means it is a block process. If it is running, it would have proceed further. If it was ready, it never hanged, right? Hanged means block because of some reason. So I hope you are getting all this, right? And this is the queuing diagram for that. Now this is a queuing diagram. Now you have, here you have new state, here you have exit state, this is running state, this is ready queue, and this is block queue. So when timeout occurs, it will directly join ready queue. When blocking occurs, it will join block queue. When event occurs on which the process is waiting, then it will join back this ready queue. Simple to understand. Now, I have a question for you. There can be number of different events because of which process is blocked and it is waiting for that event. Now, let's say it is disk event, disk IO event, suppose hard disk. Okay. Whenever hard disk is ready to be executed, ready to be accessed, whenever hard disk becomes ready to be accessed, all those processes which are blocked, waiting on disk, they should become ready. Yes or no? They should become unblocked. Yes or no? Okay. Now, what will happen if this is a single queue which manages or which maintains all possible block processes which are waiting for any particular event? What will happen in that case if disk IO, I mean disk is ready to be accessed, in that case, OS needs to find out those processes by scanning the whole queue. By scanning the whole queue, OS needs to find out each of those processes which is waiting for disk, and it needs to change its status from block to unblock, and then it will join ready queue. So again, the similar problem, that there are different types of processes which are waiting on different types of events. Are you getting my point? Yes, are you getting my point? Yes or no? So what is the solution? What can be the solution? One possible solution? What can be the one possible solution? Now you need to tell me. Exactly, different queues for different event which cause the blockage, and that is called multiple blocked queues. For every event there is one queue. So whenever that particular event occurs, all those processes in that queue will be unblocked and move to the ready queue, so that it will reduce the search time. It will reduce the search time. So this is another design, possible design. I'm not telling that every OS is using this design. This is one possible design. So again, I am reminding you that whatever discussion we are doing here, we are making here, that is general discussion. Okay, it is not OS specific discussion, because every OS has its own design. But these are some general ideas. Does this make sense? Okay, can we run processes in batches, or is it one at a time? See, what do you mean by batches? Can you give me, can you elaborate on your question?
So sir, all the events like all the processes which were blocked due to input output, so all of them will get ready at one time. So can we run all those processes at once in a batch?
See, the point is our assumption is we have a single processor. In that case, at a time, any one process is going to be executed. Okay, but the point is, the event on which those processes are waiting, that event has occurred. So we cannot keep them in block state. And that is why we free them from that. We unblock them and put it in the ready queue. And just assume about the case where it is priority based processing, priority based scheduling. We don't know what is the priority of the processes which are waiting on particular event. So we free all them, and based on priority, they will get that time. Does this make sense? Okay. Okay, another question, the process speed will remain same in this case. Again, I'm not getting this question. What is your context? Please explain. You are talking about the time slot? Are you talking about the time slot? So what is your question? Please explain.
Here the waiting time will
Okay, you are talking about waiting time for each of the type of the events?
Yes, sir.
See, they are different events. First of all, they are different events. Someone is waiting for printer, someone is waiting for disk, someone is waiting for some file to be written, whatever. So again, these are like asynchronous events. Actually, they are asynchronous events. So there is no fixed time. Someone is waiting for network data. So whenever that event happens, OS will know that through some interrupt, and it will free all this unblock process or block processes and make them unblock. Simple. So there is no fixed time for it.
Okay, sir, but I am not asking that. I am asking that the process time will remain same now.
So which is what is process time? What do you?
Sir, waiting time is different, but
yes,
but the processing time. So only one
Processing
visit
time
can
means
be-
you are talking about the time slot which is allotted to every process.
Yes, yes, sir.
Yeah, that is same. Again, see, here we are assuming that we are taking that consideration. Here we are taking in that consideration that every process is given a same amount of time. But when you learn about the process scheduling, there are different ways to schedule these processes. Okay.
Yes.
So that is why I am telling you that this is very general discussion. Case to case, it may vary, it may differ. Okay. The OS which is using this idea may not have time slots which are fixed time slot for every process. They may have used, they may be using some different scheduling algorithm. So don't consider that whatever I am talking, that is the fixed one. No, there are some different way. I mean, there are some variations on that. Okay. So we are trying to understand the perspective. We are trying to understand the different possible designs. So don't get confused with that. That is my point to conclude. Is that fine?
Yes, sir.
Okay.
Got it.
So that is why I see this subject. This is a very vast subject. In fact, every subject is vast subject. But this is, currently what is happening. It's a pure theory, right? It is pure theory that I am going through, and I am discussing general design, and you are not able to see it. The problem is you are not able to see. Like you can see everything in your programming language. You can see everything in data structure. You can understand that because you can, have some hands on that. Even in microprocessor, you can have hands on that after understanding the design. This is the only subject where I need to discuss it in general. If I take one particular OS as as use case, and then if I go into that is a different case. But here what we are discussing the general design of the operating system. Okay, so there can be different designs coming from different operating systems, and we are combining them together. So sometimes you may get confused, but that is my advice. Don't get confused. Okay, try to understand that this is the general design. Okay, fine. So suspended. I think I will continue with this in the next lecture, because anyhow after a few minutes you would like to leave, right? Because you have to go to another lecture. Do you have time, or should we start this in the next lecture? Please let me know. If you have time, I can start this, because now from 5 states we will move to 6 states and then 7 states, and to understand that we need to understand the suspended processes. Please very quickly let me know. Do you have time, enough time? Someone is having lecture, and okay, so you would like to take this in the next lecture, right? Fine. So I'll stop here. By that time we have few minutes. If you have any question, you can ask. Yeah, I will share this lecture slides. Once they make some platform ready for this, I will put my slides and video lectures there. So I'm waiting for support that they create some platform where I can share this. Priyesh bhai, if you there, please take note of this.
Yes, sir.
Are you there, Priyesh bhai?
Yes, sir. Yes, sir.
Okay, fine. Okay, any question? Someone has raised the hand. Dave Manish.
Yes, sir. Is it possible that a process can have two kinds of blockage at a time? Like it could be waiting for a printer to run and a disk at the same time. So
Just
then,
think about it. You just think about it. Is it possible? Can you do two things at the same time? That you are printing and you are opening the file in the same process.
no.
Can you write such instruction in C language? Just think about C program. Can you say print and open, or open and print? Open and print is something that can be understood. First, it will open a file and then print. So it is sequential. Are you getting my point?
Yes, yes, sir.
But the only possibility is, okay, again, there is no possibility in fact, but sometimes what happens, one process can be divided in multiple threads. One thread will do one job, another thread will do another job. And both threads can wait for some different events. That is possible. But again, at a time, out of these two threads, only one is being executed on a single processor.
Yes.
So at a time, only one blocking state is there.
Okay. And it could be possible that after let's say event one queue is that it's waiting for a printer, and
Yeah.
then it goes to the ready queue, and
Yeah.
then it has less time to process or run. So then it will go to the queue which is created for less time for running, right?
Okay, so it is possible that if any process which is waiting for some event, that event occurs, it will be unblocked, it will join ready queue, and when it gets next turn to execute, it executes the next instruction, and it is quite possible the next instruction itself is a blocking instruction and it waits for some other event. I guess you are trying to say this, right?
Yes, sir.
So
So
that
then
is
it will go
possible.
to an
Yeah, that is
queue
quite
for
possible.
another event.
Yeah, that is quite possible.
Okay.
Any more question? Okay, so let's end this session here and we will continue in the next lecture.